17. So we're going to have stoichiometry and BCA tables. No matter what you're doing, the first step is to balance an equation. It doesn't matter what stoichiometry problem is. Now, what I'm saying when I say stoichiometry is we've been doing one substance. We've been converting grams to moles or particles of one substance. Now, in chemistry, bonds are broken, new bonds are formed, and we make new substances. So, what we're about to do is we're about to have particles or moles of one thing, and we're going to have to figure out how many things of this other thing is going to produce. So, just on a concrete scale, you know, if I was making, I don't know, a peanut butter and jelly sandwich, right? Like I have peanut butter and jelly and put it together on bread. And, you know, I have to think about how much bread I have and how much peanut butter I have, and then I have to figure out how much sandwiches I can make. So that's kind of where we're going. We're going to put things together and see what we can make. So if we go out and read number 1, it says that we have 1 point. I would like you to go away. That's not funny. I'm sorry. So if you look at number 1, it says that we have 1.27 moles of bromine. So at this point, we had talked about that yesterday. Bromine's diatomic, and it's going to react with phosphorus. And basically, the question wants to know how many moles of phosphorus tribromide. So the question is, how many number of moles of phosphorus tribromide? So first step always is to balance the equation. So let me go ahead and scroll down a little bit. So we had done that yesterday. Kind of starting to get a different color. So we have bromine. I'm going to run over. So I have bromine. Maybe give yourself a thumb space or something from the edge. Yesterday I didn't give you good directions on how to draw on paper. So bromine reacts with phosphorus to give you phosphorus tribromide. So to balance this equation, this is one of the ones you can kind of look at. You can see that I have 3 bromines and 2 bromines. So to balance it, I'm going to put a 2 here, and a 2 here, and, oh sorry, a 3 there, my bad. That will give me the 6 that I'm looking for, and I meant to say a 2 there. So what that means is for every 3 moles of bromine, 2 moles of phosphorus are needed, and I will make 2 moles of these. So if these are particles, I have 2 of these, right? Or excuse me, 3 of these, and 2 of these make 2 of those, if you want to think about it with the little circles. Okay, now when we get the equation balanced, we make sure all the compounds are written down appropriately, because you do realize that if you leave this 2 off, or you don't put a 3 here, everything you're going to do is going to be wrong. So I just looked at your quizzes. The most commonly missed one is percent composition, which is easy. But it was percent composition of a compound, and then I bet you $1 you couldn't balance the charges. And that's a bummer, right? So all these things that you had trouble with kind of keep coming back. But still, most of you did fine. So our BCA table, we have B for before. We have C for change. Then we have A for after. And you can actually go ahead and, you know, draw yourself some lines. I looked at some handouts for this, and the way they had them, the little boxes were so small, I was like, whatever, we'll just draw on paper. And the big idea here, this whole chart, no matter how complex these problems get, because they do get complex, the only thing that will ever go in this table, do you remember what I told you yesterday? What's the only thing that ever goes in these tables? Did I tell you? Moles, yeah. Only moles go in here. So if you're given grams, you have to go to moles. Only moles go in this table. Never anything else. Now, let's say my 5-year-old, let's say I got peanut butter. Actually, watch how I'm going to make that bread. Oh my God, this is hilarious. Let's say I have bread and peanut butter and it makes a peanut butter and sandwich. See? That is a coincidence. That's awesome. I didn't do that on purpose. That's hilarious. But let's say I got some bread and peanut butter. I'm trying to make a sandwich. So, at the beginning, before I start, you all understand that B stands for before. Before I start, okay, how many sandwiches am I going to have? No sandwiches. So, bottom line, when you start this chart, I don't care what's reacting, you ain't going to have any products because it ain't started yet. That's what the before means. So, I'm going to put 0 moles of this. Everything I'm writing here is moles. So, every product on every reaction on everything, products are always going to be 0. Now, it did give me that I have 1.27 moles of bromine, so I can go ahead and put that right there. This is kind of like when you were in elementary school. Maybe you have those little logic puzzles your teacher would give you and have a little box and be like, such and such person ate dinner at this time, and such and such, like, who went to dinner first, you know, that kind of thing. If you didn't do that, I'm sorry. Anyway, and we're not always going to have to fill out all of this chart, but you have to figure out what they want you to know. So it says how many moles of phosphorus tribromide will be produced. We want this right here, because that's after. Have I lost you? This makes sense, right? All right, cool. So I got to solve for this. Here's the thing. I'm going to come in here. Every time this reaction happens, I'm going to lose, so minus 3 of these bromines. And every time this reaction happens right here, I'm going to lose 2 phosphoruses. And every time it happens, during the change part, how many phosphorus tribromides I'm going to have? Plus 2. These are going to be negative because you're going to, they're not being lost, right? The law of conservation of matter. We're not losing them. They're getting converted. But these individual compounds are getting lost. So minus, and I'm adding their product as new bonds are formed, the PBr3. So it says that those moles react, right? So after this is all done, if I use up all my bread, how much bread am I going to have? So you're in algebra, which I know you know how to solve an equation. If I know I start, I'm going to make sure y'all looking at me. If I know I start with 1.27 moles minus 3x and I got 0, 1.27 minus 3x is 0. Can you solve that simple equation? Now listen to me. Don't do it yet. If I find x, ain't this the same x? So can I put it like, let's say x was 4. Can I go 0 plus 2 times 4 is 8? This would be 8. Now that's nice, right? That's nice. So go ahead and solve for x, and you can do that by just below your little chart. That's another thing the charts did. I was like, I need room below. So I'm going to go 1.27 minus 3x equals 0. Your algebra is a little rusty. I don't know how you're surviving in math class, but I'm going to minus 1.27 on both sides because I want that to cancel. Whee! So I have negative 3x equals negative 1.27. And then to solve for x, we'll need to isolate the variable by doing the inverse operation of multiplication, which is division. Do I sound like a math teacher? Oh, but they don't say all that?
They're like, you know how to do this, just cancel it.
But you know, we're dividing because it's the opposite of multiplying, right?
Yes.
So anyway, x equals, notice the negative signs cancel out. I guess it's probably 0.4 or something.
2, 3.
Okay, that's good enough. So x is 0.42. So if x is 0.42, can you solve for how many moles are going to be made of this? Yes.
Why wouldn't we use the negative 2x?
Because in this situation, if you notice, it says excess phosphorus. So I know I got plenty of phosphorus. It doesn't matter. So I don't always have to have any. I'm not solving for phosphorus. Phosphorus wasn't in the game. Now later, all of these boxes are going to be filled up, and you're going to have to take everything to convert to grams and stuff. So that's going to come, but you don't always have to have all the boxes. Yes. Because if I was making sandwiches and I run out of bread, how much is going to be left when I'm done? None. Right?
Always 0?
one of them will always be 0. Now, notice in the problem it said excess phosphorus. There's probably phosphorus left over, but I'm going to run out of bromine. So that's a whole thing called limiting and excess reactants, which is on the back, which are the suckiest ones because they're the last ones. We're going to get to that. That's why we're making s'mores to make that go down real smooth, okay? So anyway, what we were doing was, I need to erase this. We were solving for how many moles we're after. So I'm going to take the same 0.42. So 0 plus 2 times 0.42 equals 0.84. And when I put this in, I'm going to put 0.84 moles. Is that the worst thing that's ever happened to you? You want to see one more?
Yes.
Yeah, yesterday I just got enough in to confuse you because the bell rang. So I was like, start over. But it's not so bad. Okay, so what's the first step we're going to do before we do anything? You're going to bounce the equation. So guess what? Number 2, you're about to bounce that equation because you already know how to do that. So read the problem. Notice how it's all words. And bounce the equation. Then I'll pick somebody and you can tell me how to do it because I forgot. No, I'm just playing. Yeah, I don't know how to bounce equations. You gotta make it till you make it sometimes. This is definitely not already balanced. That would be incorrect. Is this what you got before you balanced it? Do you need help?
No, just write it.
Balance it however you want. If you're sophisticated enough in your balancing not to have to make a chart and kind of like write it out, then that's fine. But if you need to do that, if you're using pencil, you can do it, and then erase it and put your BCA table there. That's what I would do if I had to do that, which is probably what I'm about to do. Bless you. Everybody got it bounced? Okay. So tell me what you got, please. Connor?
4 Fe plus 3O2 yields 2 Fe2O3.
Mm-hmm. And so the way do you need me to show this? Do I need to work it out? Anybody? Sure. But remember, you make a chart and you count them up, and then you go down the list until it works out. If you're having trouble still balancing equations or writing compounds, the problem is for you, you're in honors. On level, we're going to give them the balanced equations because this is a lot of stuff. But for you, you don't get that. This is what you're going to get. So all those times when I told you that it was going to come back and get you, I really meant it. And I'm sorry, but I will work with you if you need it. So let's go ahead. Just kidding. Excuse me for a second. I don't know what I did. Do you really want to? Yeah, I do. Okay, so my bad. I don't even know how to do that. But so let's go ahead and do a BCA table. So I'm going to go B for before, C for change, and A for after. So take your paper, read the problem very closely. And this is what I want you to do. Look at me first. You write down everything that you know already. And then I want you to put a box around the one we're looking for. Okay? So write down everything you know in your chart. Put a box around what we're looking for. I guess that was it. Yeah, those two things. If you understand this and you're like, I'm bored, then you just start working on your problem. Peace out. Has everybody done those two things? Some of y'all are still writing, but I don't know if you're deciding to try to solve it on your own. Okay. So, Amanda, I see you've written some things down.
Yeah.
Okay, so what? Just give me one thing that you want me to add to this.
For 4, I put 2.321. And then for the project, 0.
Yay! Now listen, sometimes when we have reactions like decomposition reaction, we have two products. Both products will still be 0. Okay, any products are 0 at the beginning. And then what did you put a box around, please? Christopher.
The after and yes, and after to the very right.
Mm-hmm. Now listen, sometimes we might be solving for the other reactant. So it's the same process. You just, use it in solving for X. So, yeah, so oxygen's extra, so we don't have to worry about it. It's when you don't know which one's extra that things get a little hairy, but that's not today, so just enjoy this while it lasts. So Anna Kate, what did you write across this change row?
You just
I said negative 4x.
Yep.
Negative 3x.
Yep.
And plus 2x.
Cool. Thanks. All right, so do we have enough information now to solve for X? Oh, wait. What's missing down here in the after? Amanda, W. What should I put right here?
0.
Sure. And please do notice that it says this one's extra. So the one that's not extra will run out. That's coming back later. All right, so go ahead and solve for X. I'll do it quietly up here on the board, and you can do it on your paper so you feel good about your algebra. Hopefully. Or not, and then we can talk about it. I know that's not all the answer, but that's the part I can do in my head. Huh? Thanks. I just could do that part in my head, and then I gave up. Thanks. Yep.
So what do you do after that? Get with
The one that I'm looking for?
yeah.
0 plus 2x equals this. So if you take what you solve for your variable, you put it in right here. So I'm going to go 0 plus 2 times 0.58 equals 1.16, I believe.
Yep.
AP Chemistry, you don't get a calculator. That's how I can do that. Good time. Anyway. What? Anyway, and you don't get one for AP Environmental either. So, for the chemistry part that's a bunch with the exponents and stuff, you do get a calculator. For the hard stuff, like the mental math easy stuff, you don't like this. AP Environmental, you never get a calculator. And it's multiply and divide longhand. You can do it on paper, of course. So, do you feel like you got it? Why don't you just start and try number 3, and of course I'll work it out. If you feel like you got it, but between today and tonight, you're gonna have to do 1 through 9. Okay. No, try number 3 is what I'm telling you. And I'll pull up the the answers are already on the blog. I'll have to pull them up. I already scanned them in. Got you. At least I gave you the balanced equation, so there's that. Isn't this kind of fun? No, I'm just kidding. It's not hard though, right? Okay. To be determined. And to be
Well, I got it. I was
So if you produce that many moles, where you going to put that information?
But since there's 2 here, do you have to multiply that by 2?
So it's still 0 plus 2x equals that. Yes? Yes. Now, if some of y'all keep working, when you get to number 4, there's different parts of the box you know. It's not always the same parts of the box. So read it carefully. So before, we don't have to worry about not all the boxes going to be filled up. Just get extra. When you have extra, you don't have to jump. So when I work in that, I work on the system, and I work in that with common sense. So I'm close to but that's why I it's exactly right. Yeah.
Okay.
Yep. Right, whichever one they're asking about. So don't let it freak you out that you don't need the whole thing. As long as you have one column all the way down, you can solve for x. And I'll say that again when your eyes are up here. Most of y'all look like you're writing. Is anybody stuck? Okay, do you see a column all the way down that's full?
Did you get 121?
If you have a column all the way down, solve for x.
1.2.
Then what do you solve?
You have to do 0.86, or wait, x equals 0.43 and then that times 30.
If you want to amend the 2 decimal places. If you want to.
How do you solve that?
You might want to do that. Okay, I'm taking it over now. If you got it, cool. If you didn't, cool. Let's do it together. So on number 3, once you start getting more things going on, it may be worth your time to draw some vertical lines. Some people were just like, 0 moles, woo! No. That will not work. So, anyway, what I was saying was, let's go ahead and fill out what we have. How many moles of hydrogen gas? So I already know I'm looking for this one. Just go ahead and put a box around it. How many moles of hydrogen gas can be produced if 0.57 moles of hydrochloric acid? Anybody lost it? You good? All right. And you see where it says excess solid zinc? When something's extra, it's not going, okay, let's go back to that peanut butter jelly I did. So if I live in a bakery, I have 87,000 loaves of bread, but I got 1 jar of peanut butter. I don't give a crap about bread. That ain't going to affect me. The peanut butter amount is going to determine how many sandwiches I can make. You see what I'm saying? So when you have an extra thing, you don't need to worry about it. It's not going to run out. It's not going to determine how many things you can make. It's going to be that jar of peanut butter that's going to run out. That's going to be a problem. All right, so anyway, I can go ahead. I know I'm not going to worry about zinc. I mean, you can put a line through it, but I wouldn't because eventually it's going to come back. Yeah, don't draw anything there. This is 0 moles. This is 0 moles. And this is 0 moles. Anybody got a question about how I did that? You're going to run out of the one that's, there's one that's excess. The one that's not excess is called limiting. The limiting reactant, like the peanut butter, is going to be 0 because I'm going to run out. And then the products are 0. So here it's going to be minus 2x minus just x. When the coefficient is 1, it's just x. Plus x plus x. As soon as you have one column going up and down, you can go ahead and solve for x. And then guess what? Put it right there and I'm done. So if you got stuck, finish now. X is probably 0.285. Does anybody need you to do algebra form? Sure. So if X is 0.285, then what's the moles of hydrogen?
0.25.
I guess you're right. 0.285 though, right? Ta-da! That's so bad. Now, number 4 is not hard. It is the same thing. But when you do number 4, it's giving you different parts of the box. You're smart. Write out the equation, write the boxes, and then fill in the parts they give you. You can figure it out, but I'm going to give you a second. Different parts of the box. Did you balance the equation right? Ammonium is NH4+. It is a polyatomic ion. Ammonia is a base that accepts the H to turn into ammonium. We don't have the knowledge of that yet, but they are not the same. How's that little chart going? Is this making more sense than it did yesterday?
Yeah, just because you have to put it for gold.
Just trying to get.
I was
Yeah.
I would. Yeah, well, we developed that.
You're smart. So now if you read, just fill in the boxes that it says. And then put a box in the box.
Where's the box?
The beginning is harder. So just getting used to school for me.
Yeah, you gotta put it under that hydrostat.
No, we didn't start in the unit. It's therefore if we did, then we would have had a unit.
No, that was pretty good too. And that's
We haven't had a
we
unit.
sent them.
We're changing subtext in the other stuff. This one, other six is related to
I'll work that part out. Oh, not the end. Yeah, as you saw. Yeah, but what I'm saying is your answer at the end should be negative. We can have a negative amount of the surface, but x should be negative. Yes, I tried. Oh. I'm very confused about the after part of it. What is this? Okay, look at your paper versus mine. You see how I can tell exactly what I'm talking about at every point in my life? You have your balance equation, and then your stuff is not guided, and then your balance equation isn't lining up with ours. So, like, I can't tell from your paper, this is 19, this is 19. It looks like a hot mess. Yeah, I know. If your paper isn't nice and lined up like mine is with the boxes underneath the balance equation, and you call me over to help you, and I, who know how to do this, can't even tell what's going on in your paper, do you have a prayer? No. So, make it look like that. Yes. Yeah, minus x plus x. You did the second row. You changed
I got 3 more. So did you solve for oxygen or solve for nitrogen?
So yeah,
It was N2O5 and H2O5. Oh, what? Oh, it created water. I mean, it was with water. Oh, how does N2O5 react? Oh, react with water.
That's I'm about to work out. Here. Okay. Yep. Here we go. Your algebra is what's failing you, not your chemistry. Your what? Okay. All right. Let's take a peek. So let's start at the beginning. Hopefully you filled in the box right. So, it says on number 3, how many moles of hydrogen, just kidding, number 4, how many moles of hydrogen gas are required? How many moles of hydrogen gas are required? Not produced, required. You see the difference? How many loaves of bread are required, not how many sandwiches are produced. See the difference in the word?
Yes. So we gotta solve it.
Yep. You're solving for H2.
Oh, no.
Okay. Are you still all right?
Yeah.
If you mess that up, I ain't mad at you. This is always 0. And this will run out.
How do we know it will run out?
Because it says,
Because there's one more after it.
yeah, because you're needing that to make all of this. So when they give you information about a variable at this point, and they're not talking about the other one, it's excess, and this is the one that's going to run out. Because if they don't mention the other one, then you know you got to know.
Will it always be 0 if that's what we're saying?
Yes, listen to me. Go with me now. One of your products will run out. Sometimes they both will run out. So if you're only given one information about one reactant, then that's going to be the one that runs out. So this will run out.
So for N2, there's no 0.
We don't need to worry about N2. And it should say it's excess, but it didn't. But And then I can come over here. This is minus x. This is minus 3x. This is plus 2x. And then, what else did I have on here? Oh, yeah. To produce 0.86 moles of ammonia. Any questions about how I did this? So now we solve for x. Who said, wait, what can I do for you? So, here we go. We have 0 plus 2x equals 0.86. So now I'm going to go and 0 doesn't matter, so I have 2x equals 0.86. Since it's multiplying by x, I'm going to divide. And then I got 0.43. Some of y'all got negative x's. Weren't y'all asking me about that? How did you get a negative x? What did you do? Did you have negative 2x here? Did I do something wrong on my algebra? If you got a negative number, please tell me. Okay. Okay. I don't think that you get your x value. I don't believe should be negative. I mean, you have negative x's here, but all right. So anyway, x equals 0.43. All right. Do you like when you do algebra? Do you like the letters x and y? Does that make you happy? Or would you like to use H2 since that's what we're talking about? We already have x. So here's the thing. Let me show you the issue. Is it time to go? Alright, this is a good one. You don't have any homework again because you still... Oh, you know what? This is your homework. This is your homework. Your homework is to not do the math, but set up the BCA table and the balance equation. You can balance the equation and put the stuff in the boxes. Deal? This page. This page. Clue number 9. So, I don't want you to work them out. Just give me the boxes and do your best to fill in the boxes. Deal?
Really quick question. When you're solving for this, you're not multiplying by 12, you're dividing. So, when you're doing solving for this box, are you dividing?
You're missing it. You should have a whole lot all the way down. You don't want to. Are you asking?
Yeah.
So I don't understand.
So you solve for x. Is it 12x? 12 times x. Yeah.
Yeah. So, Char, fill it in. If I still didn't check your homework, I was smart. I'm doing my best. Have a good day.